Okay, so welcome to part 2 of this video series showing how to use the Shiny app. Picking up from part 1, I'll assume that we all have the app up and running in a browser window. So I'll be using some example data. Feel free to download this from the GitHub page. One data set has count data, and a second data set has detection data from radio-collared moose, both of which have been simulated. Alternatively, if you have your own data, you can follow along with that as well. So either way, save the data to a location that you'll remember and that's easy to navigate to, and then click on this Browse button and navigate to the folder that you've saved your data to. So mine is in a folder called Video Proj, and upload the data set that has your counts. So when you upload it, a preview of the data should appear so that you could kind of check everything to make sure it uploaded correctly. And so note that for the column with the counts called moose, some of the values are marked as NA. And so these indicate that these sites were not sampled in the survey. So this is crucial for the package to work because missing values for the count variable are how the package determines that a site was not sampled and needs prediction. And so next we just need to enter in the options that pertain to our data set. So under response, I will choose the column with the counts, which is called moose. If there's any predictors that you have that you think are useful for predicting abundance, you can select them in this predictor submenu. So there's one that I simulated called CountPred that I'm going to check, and I'm going to go ahead and uncheck none. So it's nice if the data set that you uploaded is pretty clean and that it only has what's really necessary, because otherwise this predictors list is going to get pretty long, so it's not going to be able to tell what might be a reasonable predictor and what might not be. Next we need to enter in our column with our x coordinates, and then the column that has our y coordinates. A lot of the moose surveys are stratified, so this stratification column, we can put in the stratification variable, which is called stratum. And finally, there's a column that has an option for you to input site areas. So if your site areas are drastically different, then it might be helpful to put those areas into this column. So we'll skip detection for now. That'll be covered in the next video. If your spatial coordinates are in latitude, longitude, then you could click the yes button and the package internally will convert those into TM coordinates instead. Otherwise, just leave the option as no, and then click submit. So depending on the size of your data set, it might take a few seconds. This data set, there were 100 sites that were sampled, I believe, so it just takes a couple seconds. But if you have hundreds, you could expect it to take a little bit longer. So one of the first things that we see is the predicted total, so that's 4,537. You could kind of think about if you're using your own data, if that's a reasonable prediction or not. It's a nice way to check to make sure that something didn't go terribly wrong. But for some nicer formatted output, you could click the button at the bottom that says Get Report. And then for some site-by-site predictions, you could click the Get Prediction Data button. And so both of these files will now appear in the folder that you created in the first step. And so my desktop is a little messy. Here it is. So the new app folder that I created in the first video. The report is titled report and then whatever date it is, and so I'm going to double click it to open it. And so this gives pretty much the output here, but in a nicer, more readable format. And so we've got the predictions and their standard errors, some prediction intervals, some summary information, variogram plots for each of the stratum, so for the high stratum and the low stratum, some variogram information, the spatial parameters, and a grid that shows the predictions and whether the sites were sampled or not sampled. The prediction dataset is just called predictions.csv, and so what it is it takes the original dataset that you uploaded, so that was cut off here, and then the important columns are the site-by-site predictions, and there's a column for prediction variances and whether or not the site was sampled, and a few other pieces of information. So this is useful if you maybe want to use a different program like Python or GIS to produce maps or maybe a report, or maybe you want to use R to make your own customized report that's different than the one that's produced by default. And so the last and final part of this video series will cover if you have some detection data, what we've done to create this report and data set is assume that we have perfect detection, but depending on your application that may or may not be true. So we will cover that next.